Conference, your source for JVM knowledge.
Thank you so much for being here today in a post-lunch talk. Obviously, naps are not allowed, so I hope I can manage that you don't sleep while I'm talking about all this, because it can be a little bit complex at the beginning. Today, I'm going to talk about coroutines, which are kind of recent feature in Kotlin. But first, I wanted to talk about the inception of this talk, because I had the impression at the beginning that coroutines were quite easy to use and to apply to our code. And when I started learning about it, when the final version was released a few months ago, I realized that there are so many concepts involved that if they are not explained in a specific way, it's not that easy to understand what's happening and how we should use coroutines. So what I tried with this talk is to explain the main concepts around coroutines so that you can start using them and it's easier for you to understand how they work. So for the ones that don't know about me, my name is Leiva. I'm a freelance Android trainer. I help other Android developers to boost their careers in different ways. I've been very focused in Kotlin in the last few years, especially with the book. That was the first thing that was released, but I have also done online courses, and I'm now doing new programs like this one, Architect Coders. But yeah, my focus during the last years have been applying Kotlin to Android development and then talking about it. I have two sites, antonioleiva.com, which is in English, and devexperto.com, which is in Spanish. And if you want to follow me on Twitter, that's my handle. And said that, to explain what coroutines are, first, I want to explain what's the issue, what problem we have that coroutines can solve. So imagine that we have a simple app like this one, where we have a login, and we have to add a username and a password, and when we press login, it sends a request to the server and gets some information about the user. And imagine that once we have that user, we want to show a list of friends related to that user. If we do that in a classical way, we probably would use callbacks to do this. For instance, in the case of Android, I'm trying to do this talk as less applied to Android as possible, but probably some parts of the code are more focused on Android, but I'll explain what they do. In this case, we are just showing a progress to showing the UI that we are doing some background task or some long task. Then I would do a login request with a username and a password. And when we receive the result here as an object, we could then do the request around that user. For instance, request the current friends, and when we finish here, we could get the final user and do anything on the UI. Here I'm just showing a message in the screen, but could be whatever we need. And at that point, we could hide the progress. Here we start seeing some problems of this kind of programming, where we need to get into one callback to do the second request, and the second request would add another level of indentation. So this is what we usually know as the callback hell, when the second request gets into the first one, and this keeps indenting one after the other and makes the code much more difficult to understand. But this is a simple example, but imagine that we have a second request. Apart from the current friends request, we have to do another one with suggested friends, for instance. So a way to do it is ask for the current friends, then when they are finished, I ask for the suggested friends, and then do the merge between the two lists to show the final result, the friends that we want to show together with that user. This adds a second problem, that is that as we are waiting for this first request to finish to do the second one, we're wasting here some precious time because we could do those tasks in parallel, and we are doing them sequentially. Of course, we could find some ways to synchronize those two calls and wait for one to finish to the other one, and for both to finish before continuing the code, but that's pretty complex to write, to code. So coroutines come here to solve some of these questions. For the ones that are used to other languages, this would be coroutines are similar to the regular async await in other languages, but they are like more generic, and we'll see how they work. Coroutines, in the end, what allows is to write asynchronous code sequentially, so that we can use the result of one call in the next one without having to wait for callbacks and all that. At least the code we write could be sequential, even if we are doing background tasks to get that code. So that's one of the things that coroutines have. But the other one, when compared with regular threads, is that several coroutines can be run on a single thread, which means that while concurrent threads are limited in the Java virtual machine, concurrent coroutines are almost infinite. We can run as many coroutines as we want, and the coroutines framework will do what it needs to use the threads in an efficient way, so that we don't have to worry about that, and finish all these coroutines without issues. The other thing about coroutines is that they are very based on the idea of suspending functions. Suspending functions are functions that can suspend the execution of the coroutine, and when they finish doing a task, they give back the control of that to that coroutine. Coroutines, in the end, are a safe place where suspending functions can be run, because they won't normally, and we'll see later what this normally means, block the current thread. So this would be the same code that we had before, but written in a kind of coroutine semantic. These words that don't exist in the coroutine world by themselves. I'll explain later how we can use how we can substitute those later, but so that you get an idea. We have a coroutine block here, where we can now call those suspending functions that will be able to block the execution code. So the same as before, we put the visibility to visible here of the progress, and then we call a suspending function here that will do the login request. At this point, the coroutine gets blocked, so we can continue to do this in a background task while the thread that is used by the coroutine keeps freed. And once this is finished, the coroutine will get the execution flow here with the result of the content in this code, and this result will be. We can use it to the second request like this, with another suspending function that will again block the coroutine flow here until the current friend's request is finished. When we've done all that, we can use, sorry, this brace should be here, so don't get confused. This is all inside the coroutine. So then the final user will be created with the friend that we recover from the request, and we can show the information in the UI and hide the progress visibility. So as you see, we have gone from one world when everything was done during callbacks to another world when we write the same way as we would write it if it was sequential code without any asynchronous call. But under the hood, this can go to another thread, do whatever it needs, and then recover the execution flow here when it's finished. So these are the two suspending functions that we mentioned before. Here the coroutine will get blocked until this this code is finished. And to understand a little better how we create suspending functions, as I mentioned, they block the coroutine execution, and can run on a specific thread that we'll see later how we can configure which thread it is. And this is the way to write a suspending function in Kotlin. It's like a regular function, but we use the suspend reserved word at the beginning. With that and some other things that we need to do inside this function, we can create functions that are able to block the execution of the coroutine. So if we focus on this line here, the one that is updating the UI, as you see, this is already inside the coroutine. In which thread do you think it will be run? The ones that think that it will be run in the main thread can raise your hand. The one that think that it will be in another thread. And the one that think that it depends. Okay, we are more or less in the same. Well, it depends. It depends on how we configure this coroutine. The coroutines can use something that is called the coroutine context, and in this coroutine context we can configure several things. The first one is the dispatcher. One of the things that we can configure in this coroutine context is the dispatcher, which specifies the threads where the coroutine can be executed. This dispatcher can be provided, as we saw before here, or can be provided by the coroutine scope. We'll leave coroutine scopes to the end so that we can understand all the other things before. But we are now going to see how to specify which dispatcher our coroutines are using. So we define it here. One of the dispatchers that exist, we'll talk about how many dispatchers we have later, but one of them is the dispatcher.main, which means that this code will be run on the main thread. In the case of Android and some other UI frameworks, we usually have a main thread where the application is doing all the UI work. So we usually need to get out of the main thread to do heavy tasks, because otherwise the UI will get blocked. So in this case, if we specify that this coroutine will run in the dispatchers.main, it will use the main thread to run all this code, to run this one, but also the rest. So we'll get to another question. Where will these suspending functions will be executed? Because those are requests that we are running through a server, and we may need to block the threads until we get the result of that call. So it's important to know where these two calls are running. So in this case, it also depends. And it depends on how we configure those suspending functions. One function that the coroutines library provides is a function called withContext, which allows us to change the execution context of one part of the code. So in the case of the suspending functions, it's very useful to identify in which group of threads or in which thread this function is going to be executed. In our case, if we cover this code with context and specify dispatchers.main, then we are saying that this code is executing in the main thread. But obviously, that's not what we want, because that will block the main thread, which is what we are trying to avoid. So this is very easy to change. We'll modify this dispatcher with another one, and that fixes it out that easily. We could use a dispatcher like dispatchers.io to move from the main thread to another thread. And how all those dispatchers, well, first this thing, I wanted to mention that we are doing suspending function here to include the code that we want to do in another thread, but this with context function is a suspending function itself, so we don't need to use it inside another suspending function. We can use it directly in the coroutine scope, inside the coroutine, so we can avoid that suspended word that I invented to show the example. We can substitute it with context, specifying in which dispatcher we are running this part of the code. So these are the dispatchers that are available. The first one is the default dispatcher, which is meant to be used for intensive CPU tasks, like app processing. Every task that we do that needs the CPU to be done will use the default dispatcher, and this dispatcher only have I think that uses as many threads as the number of cores of the CPU, so that we cannot run more intensive tasks than the number of CPUs that our device has. We have another one, which is the IO one, which is used for input-output operation, like talking to the database, network, for instance, with the sensors of the device, these kind of things that are not using the CPU, but just waiting for another system to respond. In this case, we have a bigger number of threads. I think it's 64, because they are not using the CPU, and we can have as many as we want working at the same time without penalizing the performance of our app. There's a third one that is called unconfined, that I'm not going to explain it here, but it's when you don't care much about the thread that is executed, because it jumps between different kinds of threads, and it's a bit difficult to understand how it works. So unless you know what you're using, it's better not to use it. And the first one, which is only on Android, but also other UI frameworks that we can have in the Java virtual machine, we have this main dispatcher that will be focused in the main thread of our application.
Are those four only available on Android, or are they on both Android and on the JVM?
This one main, it's in several, not only in Android.
All four of them, are they?
Yeah, the other three are in every other libraries, because something I didn't say is that the coroutines are like a generic idea in the language. So you can write you can do an implementation how you need it, but then you have some libraries provided by Kotlin, so that you don't need to do all that work on your own. So there's a core library that includes these three dispatchers, and then depending on the libraries that you use, you can add this one. For instance, if you use the Android one, or there's another one about Java UI, I don't remember if Swing or one of those, that also uses this main dispatcher. So we have changed the suspended word that I invented at the beginning, but we still have this another one that specifies the coroutine scope, where it starts and it ends. And this is what are called the coroutine builders. We have several different coroutine builders depending on what we want to do. The first one is run blocking. This coroutine builder will block the current thread to run the coroutines and the suspending functions that are inside of it. It's almost never should be used, only in the case that you are doing some tests, for instance, because as we need to wait until the call to the suspending function is finished before finishing the test, this run blocking is very useful to block that test until the suspending function has finished, and we can check some things over the result. The other, well, here is an example where we can add run blocking to wait for the suspending function to finish, and then assert over it. There's another coroutine builder, which is called launch. This coroutine builder won't block the main thread, only if we use the proper dispatchers, as we saw before. And it's the basic builder. It will return a job that we'll see in a minute. What are jobs and and what can we do with them? And it also needs a scope that, again, we are leaving it to the end. For now, we are going to use one that is called global scope that we can use wherever we want. So the way to use it is like this: global scope dot launch dispatchers main. This would substitute the coroutine word that I used at the beginning. Here we need to identify dispatchers main, because otherwise it would use the dispatcher's default that we saw at the beginning. And what are the jobs? The jobs are objects that are returned by a coroutine, and that it will allow us to first cancel the coroutine and all the suspending functions that are running inside that coroutine, or wait for a coroutine to finish before continuing doing something. A job can have parent jobs, so if a parent job is cancelled, then the sub-jobs are cancelled too. For instance, imagine that we have this coroutine with a global scope launch that we saw before, and then we have a couple of suspending tasks here. If we want to wait until all this code is finished before continuing doing another task, we can use job join, and we will block here until this work is finished. This is a suspending function too, so it needs to be called inside a coroutine. Otherwise, we wouldn't be able to use it. On the other hand, we have job cancel, which what we'll do is to cancel the coroutine that is associated, or the coroutines that are associated to this job. So in this case, if, for instance, we are running suspending task 1 and we call job cancel, the suspending task 2 would never be called. This function is not a suspending function, so you don't need it. You don't need to call it inside a coroutine context. Then we have another builder that is called async, which would be the most similar to the regular async await that we have in other languages, which always needs a parent coroutine as opposed to launch that can be run as the first parent coroutine. This one needs to be called inside another coroutine, and the call doesn't block the parent coroutine, but it starts running the background task. So we call async. The background task that is associated to this async coroutine starts running, but the next line is immediately run. So this is very helpful for parallel computation or parallel requests, and would solve the problem that we saw at the beginning. This can be changed, this behavior, by using the start argument. We'll see it very quickly in a second. And it returns a deferred object. A deferred object is an specialization of the job object that we saw before, which has an extra function that is called await. This await call is a suspending function, so that's the one that will block the coroutine, waiting for the result to be completed, to the call to be completed. So imagine that we write the code at the beginning, the second one that had these two requests, the request current friends and suggested friends. If we do it with context, everything, and each call takes 2 seconds, this will take 2 seconds. When this request finishes and gets the result, it will call this one, another 2 seconds, and when the third, and when this current friends is solved, we would call this third one, and another 2 seconds. In total, it will take 6 seconds to do all this code. On the other hand, if we use async, the thing is a bit different, because as you see here, these 3 lines are blocking, and we only have this one, and well, these 2 calls here. So the first one is to get the user. We still need the user to do the other calls. So this would take 2 seconds. But then, as we use async here instead of with context, this request will start running, but we won't block here. We just continue running the third line. That will, again, do the serve request. So these two are being done at the same time. When these two when we really need the result of those calls, we call await, which is in this point, and here we'll get blocked until those two requests are finished. Here I said that both will take 2 seconds, but maybe one finishes before and the other one finishes a little later, but it doesn't matter. This will block here and here until they are finished. This one finishes, for instance, it will wait until this one finishes, and when this has ended, the result is returned here, and we can merge these two lists into the final one and save it into the user. So instead of taking 6 seconds, it will take just 4 seconds. I mentioned that the call doesn't block the coroutine, but it starts running it in a background task. This can be changed by using the start argument. We can use the coroutine start.lazy, and this means that the async task when we run until we call await. This, in general, doesn't make much sense, but imagine a situation where you can run or not run a part of that async depending on some conditions. You can block the execution of that task until you call await. So it's a way to do that lazily. And then we are reaching to scopes. The scopes would be like the limits where the coroutines apply. Scopes helps canceling all coroutines that are associated with that scope when the scope is no longer available. I don't know in other technologies or other frameworks, but in the case of Android, a very easy example of a scope is an activity. In Android, we have activities that are created when they are visible on the screen and are usually destroyed when they are hidden. Well, the life cycle is a little bit more complex, but in any case, we have a clear situation where that screen is created and destroyed. And when the activity is destroyed, probably the requests that we are doing inside that activity are no longer valid or no longer necessary. So it wouldn't be a waste of time, and also in the case of Android, a danger to continue running those requests, because if we try to update the UI when the activity is destroyed, it will throw an exception. So it's a little bit dangerous to leave coroutines or requests being executed and then getting back to the activity, because that could break our app. So the scopes work really well here. And a scope, as I mentioned, is a limit where the coroutines apply, and when we destroy the scope, those coroutines are no longer valid and won't keep executing. We have 2 options for scopes. The first one is the one that we already use. That is the global scope. This is used by the coroutines that can run as long as our application is running. So it would be a bad idea to use it in places like the activity that I mentioned before, because this global scope is never finished, only obviously when the whole app is destroyed. The other option is to extend coroutine scope, and that's what we are seeing now, how to do it. Well, the global scope is the one that we have used before, so we have no doubts here already. And the second one is the coroutine scope. This would be a way to implement it in an activity. Our activity would only need to implement coroutine scope. I'm saying an activity, but any class that have some kind of life cycle. So we implement this interface. The interface will force us to implement this coroutine scope, and there is where we configure our context. We said at the beginning that the coroutine context can have a dispatcher, but it also can have a job. So with that job, what we can do is that when the activity or the life cycle object is finishing, we can call job cancel, and all the coroutines associated to that job, which are all the coroutines that we run in this activity, will be cancelled, and we won't have the problem of updating the UI when the activity is already destroyed. So in the creation of the activity, or in the first step of the object that has this defined life cycle, we would create the job, and when that object is being destroyed, we will call job cancel. That way, when the object is destroyed, all the scope is invalidated, and the coroutines that are running will no longer update the UI. And here, that's mostly it. One thing that is missing here is that when we convert an object into a coroutine scope, instead of calling things like this, global scope.launch, we can use the coroutine builders directly without prepending anything here. So now our activity will be able to call launch, and we don't need to specify the dispatcher, the default dispatcher, because we have specified here in the coroutine context. So just by calling launch and open the braces, we would be able to create a coroutine, and that coroutine will be already associated to the job of the scope, and also will use the dispatcher that the context has specified. And one last point is that if we have we are using an API that is used in the old way, is not already prepared to use coroutines, we anyway can keep using it, because we can wrap those APIs to start using suspending functions, and that way we can use any library that we already have into the coroutines and use it in the new way. To do that, we have another function that is called suspend cancelable coroutine, which is a way to wrap those calls. It returns a continuation object that we can use when that call is finished and we get the result from the callback. This will still do the login async with the username and the password, and when it finishes, in the callback we would get the user, and we just need to call continuation.resume with the final value. With that, we now can use this suspend async login inside the coroutines in a sequential way, the same we have been using the other functions. And that's it. Thanks for attending this talk. We have now time for questions, but if you are an Android developer and haven't started still with Kotlin, I have a couple of trainings that are free that you can join, that getting into antonioleiva.com/grades in English, or in Spanish through devexperto.com. And that's it. Another thing is that, as you may know from other talks, you can rate the talks from Grids Contestia S, and there give some feedback so that we can keep improving our talks. Thank you very much.
Hi, I want to migrate to my existing repositories to use coroutine functions, but I use these repositories in a library, and many apps consume them. So if I add the suspend word to my method, my existing methods, can I use this function outside the coroutine wall? I mean, as a regular blocking function?
When you do that, internally this is converted to like a callback. And I haven't tried, but maybe when you use it from the Java world or from another place, you can use it like that. Probably from Kotlin, it will still detect it as a suspending function. But I'm not totally sure. I have not tried that before.
Okay, because I'm thinking to migrate to coroutines, but not for all apps at the same time. And if they consume the same code, I was wondering if I can use suspending function outside the suspending world.
Honestly, I haven't tried.
You have to use the run blocking in that case. If that is what you want.
So I need to add the coroutine dependencies.
In that case, in this case, is to
That would be an
create
option.
an
Yeah.
auxiliary function.
Okay.
In my code, an auxiliary function to be easier to call.
Okay. Thank you.
Thank you to him.
Any other question?
So how does this differ performance-wise from using the 4 comprehensions with monads in Arrow? Because it's a very similar concept, right? It's
I'm almost sure that Arrow used this under the hood. So I guess that if you use Arrow, that is another layer, it will be a little bit less performant, but I don't think it will be much different. But I haven't used that part of Arrow, so I can't say it.
Just an appreciation that one of the things I think is great from coroutines is what they call structural concurrency. And there are a couple of articles from people from Kotlin talking about that, and it's great. I think you can add it to the slide.
Okay, I'll check about it because I just recently started with coroutines, and as I found it so a little bit tricky to understand, that's why I created this talk. But I still have a lot to learn from coroutines yet.
In fact, the idea came from a person that works on a library in Python, and there is an article called Notes on Structural Concurrency, or Why Go Statement is Considered Harmful, and it's amazing. I totally recommend it.
Okay, if you can send it to me somehow, I'll take a look.
Maybe on contest.
Okay. Thanks.
We have some time for other question. Anyone? Okay, so thank you.
Thank you.
So-